Good morning to all of you once again. Today is the third day of myself transacting you all the chapter Classification of Elements and Periodicity in Properties, class 11 Science Chemistry. Now, in my previous class yesterday, I had taught you how to write some electronic configuration and how to predict the period, block and group of elements based on the atomic number and their electronic configuration. So that part of the chapter is over. Now let us go to the next most important part of this chapter. Okay, it is the heading of this chapter, which is called classification of elements. It is called classification of elements. So please pay attention over here. Classification of elements. Remember that the elements, they are classified on the basis of electronic configuration. Okay, so based on the electronic configuration, the elements have been classified into a number of categories. One such category is called noble gases. Noble gases. The first category is noble gases. Now, with regard to noble gases, remember that in noble gases, the elements which possess all the energy levels completely filled. Okay, they are called to have stable electronic configuration, or they are simply called noble gases. Now you already know, you have learned about the symbols and the noble gases. The first one being helium, then there is neon, then there is argon, then there is krypton, then there is xenon, and then there is radon. These are the noble gases. Okay, and if you look at helium, its atomic number, helium has got atomic number 2. Atomic number of helium is 2. Neon atomic number is 10. Argon atomic number is 18. Krypton atomic number is 36. Xenon atomic number is 54. Radon atomic number is 86. So yesterday we have already written down the electronic configuration of radon, where the valence shell electrons are found to enter 6s and 6p orbital. If we proceed further and write down the electronic configurations of all these elements, helium, neon, argon, krypton, xenon, and radon, we will find that their electronic configuration is a stable electronic configuration. Like if you look at helium, it is 1s2. Okay, the s subshell is completely filled. If you look at neon, it is 1s2, 1s2, 2s2, 2p6. It is also complete. It is stable. If you look at argon, then it is 1s2, 2s2, 2p6, 3s2, and 3p6. Okay, that is also complete. If you look at krypton, atomic number 36, the electronic configuration is 1s2, 2s2, 2p6, then 3s2, 3p6, Then comes 3D, 3D10. After 3D10, we have 4s2,
4S
4p6.
comes before 3D, no?
Pardon? Yeah, 4s comes before 3D, no problem.
4S.
Yeah, you can write it this side, no problem. 4s2, you can write it, no problem. There's no problem because I'm just writing it without following the above principle. Okay, just for the sake of writing it
Yes.
because my main target is the electronic configuration of the valence shell. Okay, 4s2, 4p6, and if you add all this, it will come to 36. Okay, that was for krypton. No, it is also complete. Now, if you look at xenon, atomic number of xenon is 54. If you write down the electronic configuration of xenon, then it becomes like this. It becomes 1s2, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, okay, then 4s2, 4p6, 4d10, okay, then 5s2, and then 5p6. So you can see all the valence shell, they are complete. The cells and the subshells are complete. Here there are two. Here there are 8 electrons. Here there are 8 electrons. Over here, if we see again, it has 6 plus 2, 8 electrons. Here also same thing. It has 8 electrons. Similarly, if you write down the electronic configuration for radon also, you will see that it has got after 5D 10, it has 6s2 and 6p6. That is also, it has got 8 electrons. Okay, so that is why, that is how the noble gases, they have stable electronic configuration. Okay,
Sir,
yes,
so I had one doubt, sir.
yeah, ask me.
So why are not using 4D, 5D in 5, 4, sir, you are not using F1, sir.
In radon,
Yes, sir.
radon.
Sorry, radon or xenon, anyone.
So because there's no need of using it because it is coming to 54. Just add xenon. You just add. Just check
Yes, sir.
xenon. 2 plus 2 is 4, 4, 10, 11, 12, 6, 18, 28, 29, 30, 36,
Sir,
46, 47,
but
48.
after 4D comes 4F, no, sir.
After 4D comes 4F, but the energy of 4F is higher. Follow the N plus L now.
Yes.
If you look at the N plus L rule, no, for 5S or 5P or 4F, then you will see that according to the N plus L rule under upper principle, the energy of 4F orbital is higher. No, just check 4F. If you look at 4F, no, it becomes what? 4 plus for the value of L for F orbital is what? SPDF. It is 3, no? It is 3. So 4 plus 3 is 7 for 4F. No? If you look at, say, look at 5P, 5P, N plus L for 5, let's check. It becomes 5 plus over here P, 0, 1. So it is coming how much? 6, no? It is coming 6. So are you getting it now? So that time,
Yes, sir.
that time you can realize that, oh, the 4F orbital is higher in energy. So there is no need of accommodating 4F orbitals. Orbitals are there, but they don't have any electrons. So there is no point in writing them. Am I clear now? Am I clear?
Yes, sir.
So,
Yes, sir.
so here is a general scheme in the noble gases electronic configuration. Now, these elements, they have a general electronic configuration NS2 and P6 auto electronic configuration. So that's why their energy levels are completely filled. And that makes them very stable, and that's why they are called noble gases. Okay. Now the next classification is known as the second one. It is known as representative elements. It is known as representative elements, representative elements, which are also called known as normal elements. Normal elements, which also called normal elements. Representative elements or normal elements. Now here, these representative elements or normal elements, now elements of the S and P block elements. Elements of S block and P block. Elements of S block and P block are falling in this category of representative or normal elements. Now, for example, if you look at the groups, like group 1, group 2, then 13, then 14, then 15, 16, 17, and 18. The elements which belong to these groups, according to the modern periodic table classification, this one is 1A, this is 2A, this is 3A, this is 4A, this is 5A, this is 6A, this is 7A, this one is 8A or 0 group. So the elements of these groups which I mentioned, they fall under this category of representative elements or normal elements. Now, under these representative elements or normal elements, again there are categories. The first category is again over here. The first category, it is called S block elements. S block. They are called S block elements. The first category of the representative or normal elements. Now, why are they called S block elements? You already know. The elements belonging to group 1 and group 2. So, S block elements, group, the elements belonging to group 1 and 2. These elements, they constitute the S block in the periodic table. And that is why they are called S block elements, and they come into the category of representative or normal elements. Now, you know, in the group 1 and group 2, the elements, you know, group 1, they are called alkali metals. For example, this one, group 1 is called alkali metals. They are called alkali metals. And you know which are the alkali metals? Lithium, sodium, potassium, rubidium, cesium, and francium. Similarly, group 2 elements, they are called alkaline earth metals. They are called alkaline earth metals. They are called alkaline earth metals. The members being beryllium, magnesium, calcium, strontium, barium, radium. These are all what? Alkaline metals, alkaline earth metals. Now, what is more important over here is with regard to the representative elements and normal elements. Under the first category, under the S block elements, the general characteristics, the general characteristics of S block elements. This becomes important. You should have read this. You must read this before the examination. They will not ask, write down all the general characteristics, but they might ask you one hidden characteristics over there. Okay, they might ask you how many electrons you'll find in the valence shell of the S block elements. So how many electrons do you find normally? Tell me. How many electrons do you find?
1 or 2.
Yes, very good. So that is how you have to remember. I'm just going to read out. I'll not write it down. Okay, some of them, like the first general characteristics, number A. Okay, they are white or grayish white lustrous metals. They are white or grayish white metals, lustrous metals. They are white or grayish white lustrous metals. Number B, they are soft. they are soft, malleable, they are soft, malleable, ductile, and good conductors of heat and electricity. They are soft, malleable, ductile, and good conductors of heat and electricity. Then the next characteristics will be they are highly electropositive. They are highly electropositive. Electropositive. They are highly electropositive and possess and have they have low values of ionization energy. That means you can easily form ions out of them. Okay, they can easily lose electrons to become cations. That's why they have low ionization energy. Then the next general characteristics is like this. They do not show variable valency. It's an important one. Do not show variable valency. Variable valency. The group 1 and group 2 elements which are under the pure S block elements, they do not show variable valency and they exist in either +1 oxidation state or +2. It is fixed in their compounds. So in the compound they will find their valencies are either +1 or +2 for specific elements. So these are some important characteristics of S block elements. Okay. Now moving to the general characteristics of the P block elements. General characteristics of P block elements. Let me discuss one by one over here. Now I already told you that P block elements are elements belonging to groups 13, 14, 15, 16, 17, and 18. Okay, and they have an electronic configuration of the valence shell NS, NS2, NP 1 to 6 electrons. Okay, in the valence shell. Now, the first general characteristics of P block elements is most of these you will find are non-metals. Most of these are non-metals. A few will be in metals. Okay, and you can find few of them metalloids also. Most of them are non-metals. Few are metals, one or two rare conditions, and then some of them are metalloids. That is the first characteristics. Then the second one, number B, the P block elements show low electropositive character. They show low electropositive character. If the electropositive character is low, then they have high electronegativity and high ionization energy or ionization potential. Okay, so this is the second characteristics of P block elements. So whenever electropositive character is low, that means electronegative character becomes higher. That makes electronegativity high, and as well as the ionization energy also becomes higher. Then number C, general characteristic of P block elements. They usually form covalent compounds. They form covalent compounds. Okay, but some will form ionic compounds also. Some will form ionic compounds also. But most of them, they will form covalent compounds by the mutual sharing of electrons. Okay. Then the next type over here is number D. Some of the elements show, some of them, not all of them. Some of the elements under P block elements show variable valency. Some of the elements show variable valency, and they exist in more than one oxidation state. They exist in more than one. Like sulfur shows variable valency. If you look at phosphorus, it also shows variable valency in its compounds. Okay, so some of the elements show variable valency, not all of them, and they exist in more than one oxidation state in their compounds. Okay, so these are the four important general characteristics of p block elements, which is categorized under representative elements or normal elements, S and p block elements. Okay, now
So,
yes,
so which are the metals? So in P block.
in the p block elements we have the metalloids. You can talk about the aluminium. Look at aluminium. Isn't it? Few of them. Aluminium is there. No? One very good example is aluminium. Okay, but you'll find metalloids also 2 or 3. Okay, over there. Then rest you'll find as non-metals. Is that okay? Is that okay? Now you spend some time with the periodic table. Okay, closely. Then you see, which I have given in the previous classes. Where you'll see it is classified nicely. It is given very nicely. Just let me go back for a while. Let me go back for a while to that chart which I showed you yesterday, the periodic table chart. If you look at the chart very carefully over here, okay, then metals are here. You can see boron over here, boron, silicon, germanium, arsenic, okay, antimony, tellurium, polonium. These come under the semi-metal category. And metals are here: aluminium, gallium, indium, tin, lead, thallium. So there are metals also, few of them. Bismuth is also a metal. Okay, so that is how you get the idea about the p block elements having metalloids also. Having what? Metalloids. Can you see the cursor I am moving over the screen? Can you see the cursor, boys?
Yes, sir.
So metalloids, and then beside this left hand you can see the metals. The first very good example is aluminium. Being a metal, still it is belonging to the p block element because of its electronic configuration type NH2 NP126 electrons. Okay, I think this is clear to you. Okay, now let us go back to our required slide. Okay, now we were here in this slide. Okay, now let us go to the next categorization. Next categorization of the what do you call the periodic table over here. Okay, coming to the next categorization. The next is number 3. The third one, it is called transition elements. Transition elements. Now, transition elements, they are also known as D block. They are also known as D block elements. Okay, now, as I have told you in the previous classes, the elements in which the differentiating electron enters into the D subshell of the penultimate shell. The differentiating electrons enters where? They enter the D subshell of the penultimate shell. Penultimate shell means n-1 D shell. n-1 D shell, it is called penultimate because after the D shell there might be ns orbital, ns subshell also. Okay, that's why here in the case of transition elements, the differentiating electron, the last electron is entering where? The D subshell of the penultimate shell. And that is how the elements, they fall into the category of transition elements or D block elements. Now, the groups over here. The groups of the transition elements are this one. The groups are, you can talk about group 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. These are the groups, okay, to which the transition elements belong. If you look at them, for example, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, this is the first series of the elements of the first series in the D block, the first series. Okay, scandium 21. This is 22, atomic number 23, and it goes on. This becomes 29, this becomes 30. So these are groups 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, now here the D block elements, they possess electronic configuration. Electronic configuration is of this type. It is of this type. Electronic configuration is of this type. The penultimate shell n-1, n-1 D subshell containing electrons between 1 to 10 electrons, and then the ns subshell containing electrons either 1 to 2 depending upon their stability. Okay, now this is also called transition series, as I've already told you. Now moving to the characteristics of the transition elements straight away, because these are the only important things required over here. Now looking at the characteristics of transition elements. Characteristics of transition elements. Characteristics of transition elements. The first one I would like to discuss and tell you, let you know. Now these transition elements, they are metals. Remember, they are metals. Most of them, all of them, rather, they are metals with high melting point and boiling point. Okay, the transition elements, all of them are metals. They are metals, and metals, they generally have high melting point, high boiling point. Okay, then the second characteristics is all of them, almost all of them show variable valency. This is something which you have learned in your lower classes. Like iron, if you look at iron, this valency +2, +3. Okay, that way. Copper valency +1, +2. So almost all of them show variable valency under the transition elements. Okay, and that's how they have exhibit several oxidation states. They exhibit several oxidation states as well. So that is the second characteristics of transition elements. Now looking at the next characteristics of transition elements, number C, the metals. I'm talking about the metals, okay, and some of the compounds of these metals. So the transition metals, and their compounds, they act as good catalysts. Okay, like for example, platinum is used as a catalyst, a metal. If you talk about vanadium pentoxide, V2O5, finely divided iron is used as a catalyst. Okay. Are you getting it? Sometimes we use this also as a catalyst in some reactions, most rare reactions. Okay, so the transition metals and their compounds, they act as good catalysts. So you will find all the catalysts which have been using in chemistry and biochemical processes, the catalyst belonging to the D block. Okay, so I will discuss this why they act as good catalysts when I discuss the chapter in class 12. There's a chapter related to catalysis in class 12. So that time I'll talk about the reason for this. Reason for that is not required over here. Then Number D, most of the ion possess unpaired electrons. So here the ions, most of the ions possess unpaired electrons. Unpaired electrons where? In their shells, in their orbitals, unpaired electrons. Unpaired electrons in their orbitals. And because of the presence of unpaired electrons, they are usually colored. They are colored. Because of the unpaired electrons, the transition elements, most of them, you'll find they are colored. They are colored. And that's how, because of the unpaired electrons, they are colored. And one more thing is that because of becoming colored, because of the unpaired electrons, they are paramagnetic. Paramagnetic. Now, the word meaning paramagnetic, I'll explain you. Paramagnetic is being affected by magnetic field. They get affected because of magnetic field. One good example is iron. Iron. It's a metal belong to D block, so it can be magnetized, it can be demagnetized. Okay, so that's how it is paramagnetic. The reason is the ions which it is forming, or the metal itself, chances that they are having unpaired electrons in its orbitals. Okay, then number E, the characteristics number E, the transition elements, they form complex compounds. They form complex compounds. They form complex or coordination. They form complex or coordination compounds. They form complex or coordination compounds. Okay. Then the last one over here we discuss. Most of these metals, most of the D block elements or transition elements, they form, you'll find them in alloys. They form alloys. ALLOYS. Okay, so these are some important characteristics of the transition elements or the D block elements. Okay, so this you have to keep in mind. Okay, so till here it is important. In the afternoon class, I'll be discussing about the F block elements. I'll be discussing about what? That is the number 4. I'll be talking about the what you call F block elements, which are called inner transition elements. They are called inner transition elements. The F block elements are called inner transition elements. Remember that. And it is F block elements. Okay, this I will discuss in the afternoon class today. Okay, and that is in the, I think it is in the 7th period at 1:10. And I request all of you, those who are already in the class, to be present, be punctual on time in the afternoon class. Okay, so now I want to talk a little bit about the project work, completion of the project work, not your practicals. I have already sent you the instruction for your practical classes. You must have watched the videos of the demonstration of the practical classes where I have demonstrated what you call, how to identify the basic radicals, how to identify the acidic radicals, okay, of the known acid radicals and the known basic radicals. Okay, now in a couple of days, after some days, I'll be demonstrating in the chemistry lab the identification of an unknown inorganic salt that I'll be demonstrating in my one of the next practical classes, like say towards the end of this month. Okay, so till the time, make sure you write whatever instructions I have sent you for the practicals in your lab notebooks, and I hope you all have finished writing your project work. How many of you have finished writing your project work? How many of you? Speak. Yeah, Stephen has finished. Stephen Gurung, you have finished? Stephen?
Yes, sir.
You have finished your project work. So if you have finished your project work, please cover it any color. Write your name, class section clearly, and write down the year 2021-2022 session. 2021-2022 session, because your project copies, they carry marks, they will carry marks, 10 marks, and your practical copies, which I'll collect later on towards the end of the second semester, before the second semester examination, I will collect your practical copies also. Okay, and let us pray to God that everything become normal so that we can come to the school and at least have hand-to-hand, one-to-one experience in the chemistry lab with the chemistry practicals. Because that is very, very important. We being in science, without entering the chemistry lab, it is very, very difficult. And I really feel very, very bad for my students not being able to do the chemistry practicals, both class 10, 11, and 12. Okay. Anyway, I'm from my side, I'm putting my best effort, going to the lab, arranging the system, the recording audiovisual system, and trying to make videos and sending for you. Whatever you understand from the videos, please go through the videos several times. Okay. Try to see how the test tube is molded by me, how I added the reagents, how the observations were made. So that is important for you all just now. Okay. And later on, when you happen to enter the chemistry lab, then you can do the chemistry practicals accordingly by following the instructions. Am I clear? Am I clear? Am I clear to all of you?
Yes, sir.
So we will meet in the
Yes,
afternoon
sir.
class once again. Let me download the attendance list. Okay. There are only 45 boys present in today's class. Okay, chemistry class. So I'll be joining in the afternoon also.
Sir,
So yes, 45.
sir, 46 was.
One is I am one of them. Okay, so 1 plus 45 gives 46. Attendance means even the organizer is an attendee, no? Okay,
The total 47.
total 47. Oh, I can see only 46
Yes,
over
sir.
here. Okay, never mind, no problem. I will get the name because I've recorded already, no? So what class do you have in the second period?
Maths.
Okay,
Maths.
so now
Man,
So maths.
see, I hope you are getting along fine with the chemistry classes. Is it
Yes,
fine?
sir.
You're getting along fine with the chemistry classes? See, you have to put effort. Whatever I teach you, try to revise it in the evening whenever you get time. It takes some time, but give some time, because the more time you give to your academics books, chemistry, physics, biology, after the classes every day, that is going to help you in the long run. Okay, so that's why be honest to yourself. Ask yourself whether you're doing the correct thing or not. Okay, be honest. Be honest. Be disciplined. Make a routine. Make a routine. Be punctual for attending the classes. Don't be late. Okay. So with this much, I would like to end my class and leave the class. Okay. So thank you so much. Have a nice day.